Today we will discuss about motion along a straight line. So far we have discussed about reference point, distance and displacement. So now we will discuss about motion along a straight line. The motion of a body. देखो मैंने कहा मोबाइल को म्यूट करो और क्लास लेते वक्त कहीं ऐसे जगह पर नहीं रहो जिससे कि बहुत सारे साउंड को ट्रैक कर सको हमेशा कमरे में रिजर्व हो जाओ A motion in a straight line, a motion of a body may take place in one dimension, that is along a straight line, and this can be represented graphically by plotting a graph between the position of the body and the time taken by it. And this is called position time graph. So right now, starting from here, we take a straight line and which is calibrated as in kilometers. So look at this, 0 indicates origin. If we move from this 0 to this side, the positive calibration will be there, and on this side negative calibration will be there. So movement along this side will be forward motion, and movement along this side will be backward motion or reverse motion. So distance measured to the right of the origin, we say this as origin and denoted by O. And just in the last class we have told you that reference point is essential requirement to describe motion of a body, whether body is moving or moving slow or fast or at rest. Without having reference point, we can't specify or describe motion of any moving body. Therefore, mathematically, a reference point is taken as a fixed point on the page or plane, and this fixed point with respect to which position of moving particle is to be specified. This fixed point is also called origin. So here this is O for origin, and here on the number lines even you can say this as 0. So distance measured to the right of the origin of the position axis, this is called position axis right now, is taken to be positive, and the distance measured to the left of the origin is taken to be negative. The origin for the position can be shifted to any point on the position axis. We arbitrarily can shift the origin to any point, but usually we take origin at a point where distance and time taken to be 0. The distance between 2 points on the position axis is not affected due to the shift in origin of the position axis. अगर पोजीशन एक्सिस को शिफ्ट कर देते हैं, origin को शिफ्ट कर देते हैं on the position axis, तो motion and measurement of motion is not affected. Next, now try to understand origin, unit, and sense of passage of time. With these things to be learned well. At origin, distance or displacement as well as time, both are taken to be 0. Now time measured to the right of the origin of the time axis is taken to be positive, and time measured to the left of the origin is taken to be negative. Now the origin of the time axis can be shifted to any point on the time axis. In the same way as in case of position axis, origin of time axis can be shifted to any position on the time axis. The negative time coordinates of the point on the time axis means that object reached that point at time that much before the origin of the time axis, which indicates past time. Negative time indicates past time. So time interval between 2 points on the time axis is not affected due to the shift in the origin of the time axis. Now, when the same point is chosen as origin for the position and time, we can take origin for the time axis separate and origin for the position axis separate, but that may be inconvenient for the observer. But if we take the position and time or with the same origin, then this is the origin, and here origin of time axis and origin of position axis both are the same at the point O. This is called origin. In that case, at origin, position will be 0 kilometer and time will be 0 hour at this location. But as soon as we move forward in this way, time and position both will change. So when we come to point A, position becomes 30 kilometer and time becomes 6 hours. On the other hand, when we reach to point B, starting from O, position becomes 40 kilometer and time becomes 8 hours. If someone asks you that what is the time taken by uh, an object moving from A to B, then how will you calculate it? You will calculate time taken by object to come from O to A, come from O to B minus time taken by object to come from O to A. So O to B 8 hours and O to A 6 hours. So difference between 8 and 6 is 2 hours. So time taken by object to go from A to B is 2 hours. Similarly, distance traveled by the object when it go from A to B is what? So you just do like that. Distance traveled by object from O to B minus distance traveled by object uh, from O to A. And obviously this is just equal to uh, 40 kilometer minus 30 kilometer, that is 10 kilometer. So similarly, the same object when reached to the point C, the time taken by the object to come from O to C is 11 hours, and distance covered by the object from O to C is 50 kilometer, 55 kilometer. So we have got it well that with respect to origin, we have described various position of object and at a various interval of time. Now, try to understand. So, okay. Next, yes, this was in discussion. Now, try to understand. Origin for position in time. This is the origin for position time. Now, when the different points are chosen as origin for position and time, then what will happen? In this case, position and time both coincide. Origin for position and time both coincide at the same place. So here, in the second case, we take origin of position uh, at a point on the line where time is minus 6 hours and position is minus 40 hours in this case. Then, one minute. Okay. Hello. Yes. So in this case, origin for time is at A and origin for position is at B. Then when we come to point C, then time taken will be 5 hours and distance traveled equal to 15 kilometers. So still if we calculate a speed, we will get same. So shifting origin for time and origin for position doesn't matter on the calculation of speed, velocity, acceleration, etc. So we have learned about origin and representation of position of the particles during motion at any interval of time on a straight line. Now let us check out next thing is important parameter that is to describe motion is distance. So distance traveled by a body is defined as the actual length of the path covered by the body, irrespective of the direction in which the body travels. Here direction is not important. So we just calculate actual path length covered by the moving body, irrespective of direction they are moving in which direction. So look at this person starts moving along a straight line in this direction and covers a distance of 5 kilometers. And then the person change its direction. Person change his direction and moves in this direction, 2 kilometers. So actual path followed by man is in this way, in this way. Okay. So now path length, actual path length will be just equal to sum of 5 kilometer plus 2 kilometer. So altogether distance traveled by the man is 7 kilometers. Similarly, say a man starts from at this location and come to this point and then return back to this point. So total path length will be 5 kilometer in forward movement and 5 in backward movement. The total distance traveled by man is 10. This is distance. As you do so, while you start from your home to school and then return back to home. So distance traveled by you is just equal to distance traveled in forward motion plus distance traveled in backward motion. And total distance is calculated. But this is not the case for displacement. So displacement is a little bit different from that of distance. Distance is a scalar quantity because it has no direction associated with it. And distance is always positive, and distance can never be zero for a moving object. But displacement is associated with direction, so it can be zero, negative, and positive. On the other hand, distance is always positive. So try to understand. Now come to the point displacement. Displacement of a body is defined as the shortest distance on a straight line. Whenever we talk about shortest distance, just take a straight line between initial and terminal point. That would be the shortest distance. But while in case of distance, we don't care about the shortest distance. We can follow any path and reach to the destination from starting point. So displacement of a body is the shortest distance between its initial position and final position along with the direction. So while we deal with the shortest distance, in that case, direction becomes important. So look at it. A person starts moving from here to this and covers 5 kilometers, and then he turns left change his direction and follow this path and covers 2 kilometer distance. Now question is that a starting point or initial point for person is here and final point is here. So what is the shortest distance between initial and final point? Just I have told you that shortest distance between initial and final point is the straight line distance. So between this point and this point, the straight line when we draw is this one, this one. So this is the shortest distance. So this could be displacement. While this plus this actual path length will be distance, and this is distance. Displacement has direction because it is always directed from starting point to terminating point or destination point. Okay, and this is north. So when you extend towards north, facing towards north, then your right hand will represent east, and your left hand will represent west, and your back represent south. So remember about the concept of directions, because as we read vector and directional quantity, just we must conveniently represent direction in this way. Okay, so next thing is that in this case, we use Pythagoras theorem to determine this shortest distance. As you know that this is the hypotenuse. So we have to determine hypotenuse. A triangle side is 5 kilometer and 2 kilometer. So we can use trigonometrical method and another method to determine this length. Okay. Now come to the point. Displacement becomes 6.57 kilometer in the direction shown by the arrow mark. But you have seen that distance is 7 kilometer, but distance becomes lesser than the distance. So displacement may be equal to distance in case of a straight line, but it can never be greater than that of the distance. Okay. And displacement may be smaller, even zero or negative, but can never be greater than distance. So in the previous case here, you have seen that a person starts from one point and reach to another destination point and then return back to the initial point. In that case, total distance traveled by the person is 5 kilometer plus 5 kilometer, 10 kilometer. But in case of displacement, if a person starts from this place, his displacement is 5 kilometer in forward direction. So forward direction displacement can be represented by plus 5 kilometers. Now, when a person returns back following the same path to the starting point, in this case, again he covers a displacement of 5 kilometers, but in reverse direction. So this displacement can be represented as minus 5 kilometers. Now, the total displacement traveled by the person equal to displacement, sum of displacement in forward direction and that of in reverse or backward direction. So plus 5 kilometer and plus minus 5 kilometer. So plus 5 kilometer plus minus 5 kilometer equal to 0. So total displacement is 0. So in case of displacement, if a person starts from one point and goes somewhere in a straight line and return back to that point, then his displacement will be 0. But distance is not 0. Again, look at here. Starting point is A and destination point is B. A ball has to go from A to B. Ball can be sent to A to B following various paths in this way. First path and then reach to B. And another one is shortest path in a straight line, A to B, directly headed towards B, starting from A. This is displacement. In this case, direction becomes dominant because its direction is always directed from A to B. So, in this case, while moving in this path, direction is not so important. So, conclusion about the displacement. What is the conclusion about displacement from A to B? Just to try to understand. Displacement is a vector quantity, and that this displacement has unit of length. As we know that unit of length is meter. So similarly, displacement has also a unit as meter, because distance and displacement uh, both are the physical quantity called length, but one is associated with direction and another is associated with without direction. So their unit will remain same because unit has nothing to do with the direction. The unit will remain same, and the displacement of an object in a given time interval can be positive, zero, or negative, but distance can never be shown. The actual distance traveled by an object in a given time interval can be equal to or greater than the magnitude of displacement, but can never be smaller than the displacement of an object between 2 points does not tell exactly how the object actually moved between those points. It only tells that in which direction object traveled and come to the destination point. So we cannot specify that which path followed by the object while coming from A to B. Just it can specify direction and shortest distance between two. The displacement of particle between 2 points is a unique path. There could not be two displacement for the same two points, initial and termination point. Only one and unique path for the shortest path between point A and B. There is only one shortest path. There can never be two shortest path between point A and B. But there can be an infinite number of paths between A and B, but this path can never be shortest. There is only one shortest path between point A. That's why we say unique displacement of particle. 2 point is unique path, which can take the particle from its initial to final position. Displacement of an object is not affected due to the shift in the origin of position x. Displacement is not affected if one shifts the origin on the position axis. Now we have to uh, just to have a difference between distance and displacement. When we ask you the question, what is the difference between distance and displacement? So first we have to know about distance. There is 2 points, two differences. So first one is distance is a scalar quantity. Second, distance is a scalar quantity and it has no direction associated with it. And distance traveled by a moving object or body can never be zero. Distance traveled by a moving object is always positive. And distance traveled is defined as the actual path length traveled by the object between initial and final position. On the other hand, displacement is a vector quantity because it has direction associated with it and always directed from initial to final position. And displacement of a moving body can be zero, negative, or positive. And displacement is defined as the shortest distance between initial and final position of a moving object. Now, so far we have discussed vector and scalar, so it is essential to know about what is scalar and what is vector. So Let us have a brief discussion about scalar and vector. Physical quantity can be divided into two categories in context with whether they are having direction or not, or whether direction is important for them or not. So scalar quantities are those physical quantities uh, which have magnitude only and no direction associated, are called scalar quantities. So, as for example of scalar quantity is length, mass, time, speed, energy. It has no direction, and direction becomes meaningless for this. Therefore, it is a scalar quantity. Now, next to vector quantity. Vector quantity is a physical quantity which has both magnitude as well as direction. All those physical quantities which have no magnitude as well as direction associated with it are called vector quantity. As for example, displacement, velocity, acceleration, momentum, force, all these have direction associated with it. That's why sometimes we say we apply force, but then one can ask you in which direction you apply. Sometimes we say bullet moves. In which direction? Direction becomes important. Then all these physical quantities are vector because they have direction. Now come to know what is physical quantity. Physical quantity is a quantity which can be measured or expressed in magnitude along with unit or without unit. First, what is physical quantity? Physical quantities are those quantities which can be measured and expressed in magnitude, either uh, with unit or without unit. So, and then we divide the physical quantities can be subdivided into two parts, scalar quantity and vector quantity. Now, example for physical quantities are length can be measured and expressed as 5 meter. 5 magnitude and meter is unit. So always magnitude expressed in a numerical value